So this is your part 6 of aldehyde and ketone. Part 6 of aldehyde and ketone. So next question based on you have to tell me the name of that reaction. So asked in 2007. Next question is 26. Reduction of aldehyde and ketone. So aldehyde general formula is RC double bond OH. So this is the general formula for aldehyde and there is ketone RC double bond OR. So this is your ketone. So aldehyde and ketone. So they are reduced. So the reduction of aldehyde and ketone using zinc amalgam. What we are using here? Zinc amalgam, right? So this is the name of compound is given. This is called zinc amalgam. So mercury name is given here amalgam, right? In presence of conc HCl. So this is your Cl. Conc means concentrated, right? So this whole reaction is called as, tell me, in the previous class, in the previous video, we have discussed about it, right? So first option is Clemenson reduction, second is Cope reduction, C is Dow reduction, D is Wolff-Kirchner.
Clemenson.
Good. So it is asked in 2007. So this is called Clemenson reduction. Name is Clemenson reduction. So what does or what happened in Clemenson reduction? Can you tell me? This C double bond O part converted into alkane, right? So this will be attached with hydrogen, right? So aldehyde will convert into alkane in the similar manner ketone also. So it will become RCHHR. So this is also alkane. Understood? So whenever aldehyde and ketone is converted into simpler alkane in presence of zinc amalgam, then it is called Clemenson reduction. So very important compound or reaction is this. Next question based 27 nucleophilic addition reaction will be the most preferred in. So what we have to do? Nucleophilic addition. So nucleophile in short form it is written as NU. The most preferred asked in 2006. Right. So which will do the nucleophilic addition? So see the first explanation. So I will write nucleophile as Nu and two lone pair. So when it is reacting with carbonyl compound, so this is the carbonyl compound general formula, right? So what will happen? This is the slow step. So in slow step, what will happening? This lone pair will go with this oxygen, so it will form minus, and this will form plus, right? So this nucleophile will attack this C plus, and the intermediate compound is formed. So this is O minus, and here Nu will attach. So this is the intermediate, right? So when it react with H plus, then it will do fast reaction. This is called adduct. Right. So I will give you the next point now. Aldehyde are more reactive than ketone. So here write RCHO is more reactive than ketone, RC double bond O. So both containing carbonyl compound, but aldehyde is more reactive as compared to ketone towards nucleophile, towards NU. NU बोले तो nucleophile. The addition of nucleophile is based upon the positive charge present on the carbon atom. So in aldehyde group is present with one carbonyl group, right? That is plus R effect, which decrease the positive charge of carbocation. Therefore, make the attack of nucleophile in ketone having minimum two alkyl group, right? So suppose compound you have to given to write the reactivity order towards nucleophile addition. So it will be like CH3 CHO first. It is more reactive as compared to CH3 CH2 CHO. As carbon increases, reactivity towards nucleophile decreases. Then CH3, suppose two times, then CO. This is ketone and it is more reactive than this compound. Longest chain is there, CH3, CH2, 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 C double bond O, CH3. So less, so what we conclude here, less number of carbon is more reactive towards NU. NU बोले तो nucleophile. NU stands for nucleophile. So write this conclusion. Now look at the next question 28 asked in 2006. A carbonyl compound react with hydrogen cyanide. So carbonyl compound general formula is R C double bond O. So there is no R written there only. So this is called carbonyl compound. Carbonyl compound. So carbonyl compound react with hydrogen cyanide HCl. So this is called hydrogen cyanide. And to form the cyanohydrin. So it forms cyanohydrin, which on hydrolysis form a racemic mixture. So after hydrolysis, hydrolysis means it react with water, H2O. So form a racemic mixture that is called alpha hydroxy acid. Alpha hydroxy acid. The carbonyl compound is. So you have to tell me the carbonyl compound. Right, 28 question asked in 2006. So suppose I am taking alpha hydroxy, right? Alpha hydroxy acid. So alpha hydroxy acid, how it look like? There will be C, CH3, H, COH. Here OH. Alpha. Alpha means second carbon is attached with this OH and one functional group will be carboxylic acid. So see here. So it starts from two carbon compound like CH3, C double bond OH. So this is your meth. So it is your ethanol aldehyde group. When it is reacting with hydrogen cyanide, so what happened? This is your H plus and this become minus. And as we know, oxygen form minus and carbon form plus. So this H plus go with this OH minus and this CN will attach with Cl. So formation of cyanohydrin. So this will be the formation. So right here CH3, C, OH, here H, and this will be the cyanide. Right. And when it does hydrolysis, so here doing now hydrolysis, H2O. So what happened? This cyanide group is converted into carboxylic acid, right? So you can see clearly here. This is your methyl group. I have written here methyl. This is H, this is H, right? This is OH, this is OH, right? So when we do hydrolysis, what happens? Cyanide group convert into carboxylic acid. So this will be the final product. So write it down. And this is called racemic mixture. Why it is so? When we are taking the mirror image of this one, so this OH will come here and H will come here. So formation of another compound is there also. So write it down fast. Now look at the next question, 29. The major organic compound formed from the following reaction. So this is your reagent, C double bond O R. So here reaction is happening step by step. So in first step, so this is the compound given to you if first reacting with methylamine, right? Asked in 2005. So see here, first it is reacting with methylamine. So what happened here? Uh, this is a chief base, right? So see how it is happening. So this group will form like this, CH3, NH, this, so see here it is NH2, right? And this is O. So removal of this one, H2 and O will happen. And this nitrogen will attach here directly. So the formation of compound will be like this. C double bond in CH3 and water is coming out as a byproduct, right? So when it is now reduced in second step, we are using here lithium aluminum hydride, So what it does, it produces hydrogen. Name of this compound is lithium aluminum hydride. So this is your reducing agent. This is your reducing agent. Reducing agent. So what do lithium aluminum hydride? It produce hydrogen. Produce hydrogen. H plus. So H plus is also called as what is called? It is nascent hydrogen. So see here. So one H will attach here and one will be attached here. So addition of hydrogen will be there. So this is your NCH3, right? So one hydrogen will be attached here and one hydrogen will be attaching here. So double bond is converted into single bond. Single bond. Right. So this is called second degree alcohol. No, second degree alcohol, no, amine. Second degree amine. Second degree amine. And I will give you the general formula for amine. So amine is RNH2. So this is 1 degree amine. Right. 2 degree amine will be RNHR. So it is 2 degree amine. So when N is there, so this is your R group and this is another R group, this. So when nitrogen is attached with 2 R group, then it is called secondary amine. And when it is attached with 3R, then it is called tertiary amine. 3 degree amine. So write it down. This is called H-chief formation. H-chief base. H-chief base. Right. Why it is called base? Here, lone pair is having with this nitrogen. That's why. Now see the next question, 30 number. Which one of the following can be oxidized to corresponding carbonyl compound? Right. So it is doing oxidation. Suppose I am taking A as a reactant and it does oxidized, right? And forming two carbonyl compound, C double bond O, right? So this is called carbonyl compound, right? Asked in 2004. So 2-hydroxypropane. Suppose I am taking here CH3, CH, CH3, here OH. This is 2-degree alcohol. How will you identify 2-degree alcohol? Like RCOH and R. This is 2-degree alcohol. So when OH group is attached, that carbon should be 2-degree. So here one is group is attached. This is R2 group is attached. So it is 2-degree alcohol. 2-degree alcohol. Right. So it is oxidized. Right. So what do you mean by oxidized? So it is reacting with oxygen, or it does tautomerism. So here OH group is there. Right. So it will form like ketone. Right. So it will be CH3, C double bond O, here CH3. So in oxidation, we are removing these two hydrogen, this part. Right. So it is forming ketone. So this is called oxidation. So see here. So I will give you the brief recap. So when aldehyde is there, like R C double bond O. No, I am taking first alcohol, 1-degree alcohol. So this is your OH, and this is not bond. So I will cancel it. So this is your H, right? So this is your 1-degree alcohol, 1-degree alcohol. So when 1-degree alcohol do oxidation, so when it is reacting with oxygen, formation of aldehyde will be happening. So this H2 will be removed. So it is forming RC double bond OH, and hydrogen will be coming out. So 1-degree alcohol is converted into aldehyde, right? In the similar manner. So when 2nd-degree alcohol like or ketone like R, 2nd-degree alcohol RCOH is there, and here R, and there is one H. So when this carbon attached with 2R, then it is called 2nd-degree alcohol. So when 2nd-degree alcohol does oxidation, it forms ketone. So removal of these hydrogen. So it will be formed RC double bond O R. So this is your ketone. So 2-degree alcohol is always converted into ketone, and 1-degree alcohol is converted into aldehyde. And when 3-degree alcohol is there, like R, C, OH, R, R. When three R are there, this is called 3-degree alcohol. 3-degree alcohol. So when it does oxidation, it forms alkane like R, C, R, R. So it forms, what does it forms? It forms alkene or alkane, right? So double bond R is there. This is your alkene, right? So write this one. So in question number 30, question was which of the following can be oxidized to carbonyl compound, right? So we have taken A here as a reactant and we are doing oxidation, right? And forming carbonyl compound like RC double bond O, right? This may be aldehyde and maybe ketone, right? So options are given. The first option is 2-hydroxy propane. So propane. So can you draw the structure for this? So this is meth, eth, prop, right? And 2. So this is your 2-hydroxypropane. And one B option is, so draw the structure orthonitrophenol. This is your phenol OH. This is group is called ortho, right? So here attach is NO2. At ortho it is NO2. So name of compound is given ortho nitrophenol, right? And C option is phenol. So phenol is nothing but OH group is attached with this benzene. This is your phenol. Next option is D. That is 2-methyl 2-hydroxyl propane. Propane. So for propane, meth, eth, prop. Second group is CH3 and this is your 2-hydroxy. Right. So we have taken this compound, right? Why it is 2-degree alcohol now? This is 2-degree alcohol. So we are forming carbonyl compound. So as I have told or explained that 2-degree alcohol is converted into ketone. So this is your ketone and ketone is also called as carbonyl compound, right? So in ketone, this group is functional group is there. So this functional group is also called as carbonyl compound. Carbonyl compound, right? And this is 3-degree alcohol. This is 3-degree alcohol, right? And when it does oxidation, it forms aldehyde. So here CHO will be there. And when it does oxidation, this is also converted into aldehyde only or carboxylic acid, right? So your first option will be correct. So add these 2 points for question number 30.